very good evening to President IAPT, Professor P.K. Ahluwalia ji, Professor H.K. Sehjwani, President RC01, Professor Meenakshi Syal, convener of the workshop, Professor Pragya Nopani, Mr. Jeevan Pandey, and Professor Basu Sahu, resource persons of the workshop, all respected dignitaries and all the dear participants. Welcome to the sixth and concluding day of our workshop. It has been an enriching and intellectually stimulating journey over past few days, filled with insightful discussions, active participation, and meaningful learning experiences. We all are delighted to continue today's session with our esteemed resource person, Mr. Basu Sahu, whose engaging and thought-provoking sessions have greatly benefited all of us since yesterday. His practical approach and clarity of concept have truly enhanced our understanding. So we wish to continue the journey that is given by our very intelligent, very clear Vasu sir. So over to you, sir.
Thank you, ma'am. Good evening, everyone. And this session is basically the application part, what we have learned yesterday. In this session, we will learn basically something special about pseudophores, how we can apply pseudophores in non-inertial frame, what it's actually meaning, why we call this as a inertial frame, even it is applied on non-inertial frame of reference. This kind of query things you will understand in this class. So be patiently listen everything, and it will be better if you communicate with me. And if I received various questions from your side, that will be helpful to everybody, even for me. So in this note, I want to start this session. Thank you, ma'am, and let's start. Basically, yesterday, what we have seen this particular problem with respect to specifically inertial frame, and we understood that the frame of reference of truck is basically non-inertial frame of reference, and to apply Newton's second law in non-inertial frame of reference, we have to make some adjustment, and for that adjustment, we apply a pseudo force. In this session, we will learn how we can apply pseudo force and on what extent it is applicable to the bodies. Let us start. And we have seen yesterday this cartoon of Newton as a reference frame, and frame of reference S dash was fixed nearby this. But as Satrupa ma'am said yesterday, we can fix this frame of reference at the roof or the point of suspension. The same thing I have done here. Then what will be the difference between yesterday discussion and on this discussion? Is there any difference? What do you think? Participant, please interactive so that we can understand the concept behind these all things. Anyone please volunteer. Is there any difference between the if we fix this frame of reference here and here?
So it is still in the accelerating frame, so I don't think there would be difference except the sign of coordinates will change.
Yes, only the relative position of this bob will change, but in terms of velocity or in terms of acceleration, that will not affect the point of basically origin of this s dash will not affect any kind of thing. So for that we have understood that we have to apply this pseudo force F is equal to ma on the bob, right? We have understood yesterday this up to this thing. And my next question is, suppose we want to write the equation for this bob, what option is correct? T cos theta minus ma is equal to 0, T cos theta equal to ma. Both is equally similar in terms of mathematics, but in terms of physics, both have different uh, meaning. Choose accordingly what meaning you are taking in non-inertial frame of reference. Please put your answer on chat box. Ma'am, please help me out. What are the options voting for option A and number of votes for option B?
Okay, sir.
Then we will discuss about this. I have not prepared poll question for today's session.
Sir, can you please repeat?
Ma'am, I have shown here two options, option A and option B. You can see in the slide. Option A
Actually, the
is
slide is not transitioning.
slide is not.
Slide is visible, ma'am. Two option A and B are there.
It is visible.
You have to choose one
Got it,
option.
ma'am.
Which option is correct? Okay, option B.
Sir, all options shared here are B.
B.
Option B. Option B. Nobody is saying about option A. Why? Okay, more or less everybody is in the same line for option B. Oh, somebody has written both options seems to be same. Yes, it is mathematically same. In terms of mathematically, both options are same, but both options have their own physical. In terms of physics, they have different meaning. Okay, ma'am, let's start discussion. Can anybody tell me why option B is correct? Why option A is not correct? With respect to frame of reference S dash.
Sir, option A is saying the resultant force like T cos theta and minus of MA. That means net resultant maybe T cos theta is greater. We can think of it like it. And minus of MA is 0. But since we are trying to apply Newton's second law in accelerating frame, so T cos theta for the justification should be equal to MA.
Okay, okay. Mamta ma'am said A option. Ma'am, please, why you have chosen A option?
Actually, in S dash frame, uh, there appears no acceleration actually for the Newton sitting inside the truck. So I think we can't take second equation. We can take first, where MA is the pseudo field there.
Okay,
I'm not sure is it correct or not.
okay, okay. Let me explain, ma'am. Just a 1 minute. Just a minute. Actually, what is FP is equal to MA shown in the figure? Whether it is force or something else. First, understand this. Whether it is force or something else. Anybody, please?
Component of tension.
Component of?
Tension.
Sir, it is the
No,
pseudo force.
MA. If you just talk about FP equal to MA, whatever I have written there, that is force or what is this? Something else.
Sir, probably, I may not be correct. This FP is the force as seen by the observer on the ground, which has the acceleration in the opposite direction, A dash. So for him, that is the pseudo force, and that is equals to MA. And
Hmm.
apparently, FP and T cos theta are same. They are equal.
From which observer you are observing FP is equal to MA? From the ground
The
observer.
from the ground, from the ground.
From the ground, there is no FP force because ground floor observer fixed on the ground, we are considering like inertial frame of reference. In inertial frame of reference, you cannot observe any pseudo force. Fv is a pseudo force, then it cannot be observed by ground observer, first of all. So this statement is absolutely wrong. The
Secondly,
ground observer will observe Fp is equal to Ma. He will not observe any kind of this kind of force. He will observe only Mg. He will observe tension T. That's all.
so this
So
is
who
for
is observing Fp is equal to Ma?
the S dash frame.
From S dash frame, right? From S dash frame, we are considering Fp is equal to Ma as real force. Although it is pseudo force, but in the frame S dash, you can consider pseudo force as real force. But you cannot define the materialistic origin for this force. But remember, this is force we can define in non-inertial frame only. So this is basically force. Ma is not like mass times acceleration. It is just a force. Here t cos theta is just a component of a force. So now what is happening here? With respect to frame of reference S dash, this bob is not moving. What was the equation when we manipulate our Newton's second law in non-inertial frame of reference? The equation was F external plus F pseudo force is equal to mass time acceleration observed in S dash frame. This is the equation. Here, the acceleration observed in the S dash frame for bob B for bob is basically A dash is equal to 0. Real force is T cos theta, that is external force. Pseudo force is Ma. Both are acting in opposite direction. That's why we have put here a minus sign. What about acceleration? S dash is 0. That's why we have put here 0. So this option A is correct. Option B is not correct. Option B, what option B is saying? Option B is representing in terms of ground observer. What ground observer will observe? Only T cos theta component, and accordingly ground observer will say, yes, this force is equal to mass times acceleration what he is observing from the ground, and the acceleration of this bob with respect to ground frame of reference is basically A. So this is the basic difference between these two equations in terms of physics. Both look like similar, but they are not similar in their physical meaning. Everybody is in same line, or do you have any queries in this regard?
Clear, sir.
Fine. Okay, thank you so much. What about this person? This is not now, I am not considering this person as a frame of reference. It is a complete a person. What would be the acceleration of this person? I have already written here. A dash is equal to A. Everything we are considering now from the frame of reference as that S dash itself. That's why A dash is equal to A. Basically, it is moving in this direction. This person is moving in this direction. How can I justify the movement of this person? Can anybody tell me? How can I justify?
For S dash frame, this man appears to be accelerating in the opposite direction of the truck.
Yes, but my question is why the person or man is accelerating? Because we know for the acceleration we need force. So where the force is coming from?
This is actually a pseudo force that is not a real force. It appears to act.
Okay, that means you want to say like this kind of force is acting, right?
Yes, sir.
Is it what you want to say?
Yes, sir.
Okay. This is the basically clarification for the movement of this person. A pseudo force is acting on the man, that is F dash P is equal to ma, and this force is causing the motion of the person in this direction. And here the acceleration observed by this S dash frame A dash is equal to A. The equation will be F dash P. Now, next question. Sorry, I will not tell you the basically answer. Now choose option A or option B is correct as per your present understanding. Which option is correct? Option A or option B?
So could you please repeat the question?
Ma'am, I have again shown two options, option A and option B. Which option is correct with respect to S dash frame? F dash P is basically pseudo force acting on the man, and everything is written there. Okay.
Excuse me, sir.
Yeah.
Uh, how these two options will be different that way? Because in
Ma'am,
option A, you have said FP dash minus MA is 0,
hmm.
and in option B, FP dash is equal to MA. So,
Ma'am, as I said earlier, don't think in terms of mathematics. In terms of mathematics, both options are correct. But both option has their own physical meaning. Accordingly, you have to judge.
okay, sir.
So what sir is trying to say is that mathematically both the options are they mean the same thing, right? That's why you are asking that they don't seem to be different. But then if you look at the implications for physics, the physics behind writing each of these options is different.
Yes, ma'am.
So what is
That is
that
why I want to
physics
highlight.
that is bringing us to these two different options, and which option should be correct for from the point of view of physics of this frame of reference? Am I right, sir? Have I been able to say?
Yes, ma'am. Yes, ma'am.
Sir, option B,
Option
F
B.
dash is
Okay.
equal to MA is correct because F dash
Okay.
P is equal to MA. It means it appears that it is equal to MA. And the option A equation, F dash P minus MA equal to 0, says that the two forces balance each other.
Yes, sir. Yes, sir. One thing I wanted to highlight when we say appears, that means we have some pre-assumptions about the motions, and that is what we very well know. Nobody can move uh, on the earth if he has just standing there without any force. What I want to say, if somebody is standing on the earth, that means we have pre assumptions that yes, he cannot move without the force. But in S dash, he moves. That's why we say it appears like that. But this kind of thing is absolutely not correct in terms of physics. In terms of physics, with respect to S dash, that person is moving. That is the reality. It is not appearing like that the person is moving. When we say appearing, that means we have one assumption that the person cannot move. But we are thinking like that the person is moving. But this is the not reality in terms of physics. We really don't know whether person is moving or this car is moving in terms of physics.
Sir,
Hmm.
sir, I have a question. Like yesterday, we discussed about non-inertial frame.
Hmm.
So, and you said that it should not be relative to something else. Like from the non-inert frame of reference of truck S dash, which is non-inertial, We
Hmm.
are not allowed to say that the man's frame of reference is non-inertial.
Hmm. Right.
But everything is happening like a non-inertial frame, like we are applying the non-pseudo force on the man also. So why don't
Hmm.
we called from the frame of reference of truck that man is non-inertial, is in the non-inertial frame?
Actually, I have discussed this thing with Nopani ma'am yesterday in the evening after the class. The main story becomes from what we have taken a basic assumption about space and time. What we have assumed, that is the first thing, is that space is rest in absolute sense. With respect to space, everything is moving or it can move, but space will not move. If I apply your logic like that, suppose something is moving with respect to space, then I will say with respect to that person or that body, space will move. But physics do not allow this thing. Physics clearly say space is in absolute rest. That means everything you have to define with respect to space which is in absolute rest. So what is meaning now? Meaning is that when we assume Earth as an inertial frame, that means there is one tricky thing. First, we have to do experiment. When we have do some experiment like Foucault pendulum experiment or something, or it shows, okay, Earth is like inertial frame. That what we are basically meaning of this, we are considering Earth with respect to absolute space moving in the constant velocity path or just stationary. Then only Earth can be inertial or non-inertial. Otherwise, Earth will have something basically acceleration. Some acceleration Earth will have. But when we assume Earth like that, then we are comparing everything with respect to absolute rest space. That's why it becomes every frame of reference has their own inherent property, and that inherent property will be compared with respect to absolute rest. We cannot compare with respect to each other. That's why I always said yesterday, inertial frame or non-inertial frame is basically inherent property of a frame of reference. Why? Because we cannot compare each other. We have to compare this property with respect to absolute space. This is the basic funda. That's why we are not saying here the truck is basically non-inertial frame of reference with respect to Earth. Why we are not saying? Because we have compared our earlier assumption, Earth is an inertial frame with respect to what? Absolute space. That means whenever you know something is inertial frame, then you are free to compare not free to compare. You can define whether the frame will be inertial or non-inertial with respect to observing the non-inertiality or inertiality property with respect to the frame of reference. But the terms will use inertial or non-inertial. We will not say with respect to Earth or with respect to something, because with respect to Earth is itself with respect to something that is absolute space. That means if you are defining with respect to Earth some frame of reference is inertial, that means you are indirectly defining with respect to space. So these kind of things basically goes on. So everything we define with respect to space, knowingly or unknowingly, with our assumption. Are you getting my point, Manish, sir?
Oh, okay, sir.
Okay. So now continue with our discussion. I think we have find out the option B as the correct option. For this particular case, absolutely what we are observing with respect to frame of reference as dash, the main is moving opposite to the direction of basically this truck. When we see from the inertial frame, it's just moving, suppose x direction, then truck is moving in x direction, then man is moving in minus x dash direction. Yeah, x dash direction, you can say. And what we are applying? We are applying, first you ask, what is the F external acting on the man? Can anybody tell me? What is the real force acting on the man?
0.
Ma'am, when you say 0, in what direction you are saying? Just
He is
draw a free body
stationary
diagram
actually.
in your mind.
He is stationary with respect to ground. If we take him as a with respect to ground, then he is stationary, means no force is acting on him. But when we consider him with respect to frame of reference as test, then he is moving and the pseudo force is acting on him.
Are you sure कि no force is acting on the man? I am again speaking. In which direction you are
Gravity is
speaking?
there like that. All other forces.
Yes, yes. External force, gravity is working. What other force is working on the man? Normal force.
Normal force of
Yes, normal force. And gravity and normal force are basically cancelling out each other. But in x direction, no force is acting. Only this pseudo force is acting. Remember our equation? F external plus F pseudo is equal to basically what? Mass time acceleration observed in S dash frame. Acceleration observed in S dash frame is basically A dash A, and F external is 0. That means option B is valid, not option A. What option A said? Option A said F dash P minus, we are something considering like ma is also a force. I don't know why we are considering like that, is equal to mass into acceleration is 0. So I don't think this kind of reality is being here for the man. So that's why option B is correct. Somebody has told, consider like, sir, can we consider friction force? Okay. Can we consider friction force? Obviously, without friction force, the person may fall down. But here we are not considering friction force.
I mean, he is standing without any slipping.
Without any slipping, right? Without any slipping. If he will slightly tilt or something just deform his body, so he may fall down due to slipping if there is no friction between earth and ground. If we are not considering F is equal to like 0, we are considering F is equal to like 0, then a small disturbance on the man can fall down him because there is no friction force.
Okay.
So we are not considering like that, because everything like earth is also moving with respect to S dash frame. So you can, it is easy to not to consider friction force.
Okay.
Let us move.
In which case,
On what on which body this friction force can be applied? Can we apply on driver or this cartoon of Newton or some Larten table? Can we apply this pseudo force? All are inside the basically this frame of reference which we have assumed. Truck is basically assumed as a frame of reference as dash. Can we apply pseudo
Yes, sir.
force on Newton's cartoon and that driver and lantern
Yes,
table?
sir.
Acha, okay, we received answer like yes. Anybody who will say no? Okay. Can we apply pseudo force on truck?
Sir, I feel pseudo forces come into picture only when we are trying to figure out an explanation for a displacement where the acceleration itself is not sufficient.
That means you want to say the things which are not connected or loosely connected, or we can say simply they can move with respect to the frame of reference as dash for which we will apply pseudo force, like, right? What you want to
Yes,
say?
sir. Yes, yes. Something like that, yes.
Okay. Suppose look about this particular door. This door can move with respect to this S dash frame because it is loosely connected. If it is rigidly connected, then there is no need to apply pseudo force because our concept will be something wrong because we have assumed this truck as a stationary. That means we have considered like something rigid body kind of things. And you are just this basically three directional x, y, z direction is just some kind of things you can see it is just a denoting the position of the some uh, particles. It doesn't mean that the this particular truck we are assuming like uh, frame of reference. If you take some part of this truck, then also you have to apply because you are chosen some system here. You have chosen some system here. Suppose I am uh, considering this part, then I have to apply pseudo force also because I want to analyze the motion of this part. Then what I have to consider? I have to consider not only the pseudo force, but the force created by nearby atoms. And that will be, we can collect in terms of stress. Suppose, look at this window. Suppose here a loosely connected window is there. What will be the destiny of window? If the acceleration will increase, it may go back. Matlab, it may burst out due to the high pseudo force in terms of S dash frame. Why? Because we are considering the pseudo force here also. It can move with respect to this frame S dash.
That means,
Simply,
are we considering air resistance here?
not air resistance. Anything that can move with respect to S dash frame, we have to apply pseudo force concept. Whenever you are choosing something as a system, you have to apply pseudo force. That is the basically concept. When you are looking from the frame as dash, it doesn't mean that the part of this truck we cannot apply pseudo force. We have to apply because there is no difference between this bob. Just suppose this bob is connected to a rigid rod and rigid rod is fixed with the help of welding here. What will be the destiny of this rigid rod with bob? Whether it will go like this or it will directly stand over here.
It will remain stationary as it.
Re- yes, remains stationary. What we have assumed, truck as a remains stationary. After that, if you apply pseudo force here, what will be the effect? This pseudo force will try to turn here, but due to welding with the roof, this will not allow to move this way. That means some force, when you will draw the free body diagram of this bob along with this rigid body, what will be the forces? One force will be here like pseudo force. One force will be like here, like pseudo force. The reaction force coming from the welding portion in this side so that they will cancel out. Not only that, the the torque of this force will act in this direction like this inside inside the plane of this particular slide, and the reaction torque will come out outside of this plane and they will cancel out. So this is the concept of rigid body. When we consider a rigid body, then we have to take the proper reaction generated by the internal forces also. That is what I was highlighting here. Suppose you are considering this part as a system, then also you have to apply pseudo force. तो इस डायलेमा में कभी मत रहिएगा कि सूडो फोर्स ओनली वी विल अप्लाई ऑन द बॉब ऑन दिस पर्सन लालटेन बिकॉज वी आर वेरी acquainted of doing this because we think it is loosely connected or we want to analyze the motion of this. Whatever you want to analyze the motion of the things from here, you have to apply pseudo force. This is the concept. it does not create any difference between this bob and the bob connected with the rigid body. There is no difference. You have to apply. If you want to analyze this particular bob connected with rod as a system, so first define system for which you want to analyze the motion of that system. First you define system. Here the system was this bob, that's why we apply here. Here the system was man, that's why we apply here. Suppose the system is this person Newton. Now Newton we are assuming as a proper person, not like observer. Then you can apply here, you can apply here, you can apply here, even for this door, even for this door. And what I earlier said, suppose it is connected with a rod, rigid rod, then also you have to apply. That means everywhere, if I am taking a system, whether it is inside this particular truck or outside this particular truck, we will always apply a pseudo force, because see this arrow sign. Arrow sign signifies that this frame of reference is not confined for the truck, rather it is extended to entire universe. Everything in the universe you have to apply pseudo force if you are observing that particular body from the frame of reference S dash. Up to this point, everybody is on the same page or something else? Do you have any queries? Where we should apply pseudo force, where we should not apply pseudo force? Then we'll move ahead. This is very important concept.
Sir,
Sir,
pseudo
can
force.
you elaborate? Yes.
I think we should move ahead. Okay. Now, this definition is very important. What I said, pseudo force applies to every particles, applied to everybody for which we want to analyze the motion from the S dash. Whether it is part of that frame of reference or not, it doesn't matter. That's why we call it as a inertial force. All pseudo force have their common name. Whether we call it pseudo force because its materialistic origin we cannot define, that's why we call it a pseudo force. But it is in the same terms, it is known as inertial force. Can anybody tell me why we say like this, inertial force? What is meaning of inertial force? The same pseudo force, meaning is same pseudo force, but why the different name is there? Inertial force. Why we say inertial force? Have you acquainted with this term, pseudo force, inertial force?
Sir, it is due to inertia of the body.
Sir, inertia is very obsolete concept. It was initially put forwarded by Newton for some reason, but after that there is lots of problem with the definition of inertia. Now the concept has completely obsolete. We cannot use inertia kind of thing. I can take a separate class on that. So please vanish all these idea. Inertia, don't use inertia. Try to not to use this kind of word because it is now obsolete concept. There is some special meaning for using. We are basically carry forwarding the inertia with respect to historical reference only, but in physical meaning is something now we have changed. Why we call inertia is very interesting thing. Just see the equation. Suppose we write Newton's second law in inertial frame of reference. What we write? F is equal to ma. I am again repeating, F is equal to ma we write in the inertial frame of reference. What is F? F is basically external force. What is m? M is simply we call now m as a mass of the body, and a is the acceleration of the body. In the time of Newton, there there was basically two kind of mass. First mass we call inertial mass, and second mass we call gravitational mass. There are two different kind of things, mi and mg. What is mi, mg? mi always appears with Newton's second law. F is equal to mi into a. And mg was attributed to gravitational mass, like gravitational force F equal to mg into g. Matlab, you just think like that. G is in subscript of the m. Basically, we are considering two mass, mi and mg. Why I am saying like that? Because it was think at the time some inertia of the body is present there, and when we apply some force that resists, and accordingly some acceleration was generated by the force. That's why F is equal to mi into a. The important thing was carried forwarded from here, that was the inertial character. Means something inertia is there, that's why we are representing some mass, and that mass is basically a proportional constant, F proportional to a, and that proportional constant is basically mass. What I want to say, for example, suppose there are various kind of force like gravitational force. We define mg. Mg is the basically gravitational mass, mg into g. For electrostatic force, we define q into e. For some other forces, maybe somehow we define something else. But in Newton's law, all forces, whatever is the nature of the force, all external force is equal to mi into a. In the similar note, physicist has defined this pseudo force as inertial force because all pseudo force is proportional to some mass of the body, and this mass of the body they denoted like mi, and acceleration alpha. This acceleration alpha is basically frame dependent quantity. So that's why this pseudo force is applicable to every particles. That's why we call pseudo force like Fp is equal to minus m alpha. I am not writing here alpha as directly a, as I shown earlier, because alpha is a frame dependent quantity and it has basically proper meaning. It depends on the frame. If frame is rotating, the meaning of alpha will be changed. If the frame is as translating, the meaning of alpha will be something else. But the meaning of m will remain same whether it is translating or rotating. It is just an inertial mass, but we don't use now the word inertial mass, but we have retained the concept inertia and accordingly inertial force. Yes, Rahul sir, बताइए
Uh,
what you want to
uh,
ask.
Actually, uh, I was gone for some time also, 5 7 minutes. Maybe I missed some things also, but just see, pseudo forces are obviously the name itself says pseudo, and the use of them, they're actually a mathematical construct only, just to ease the way of solving the problem. That's what my understanding is. So it's like the way I look at them, or I have been looking at them, is more like just like we take the case of relative velocities. So when we are observing the velocity of one object with respect to another, we have to make the object from which where they're observing, we need to make it to come to rest. So to make it to come to rest, sort of if I add a negative velocity of that itself object, that will come to rest. The same adjustment I should now make in the other object so that I can get the relative velocity between the two objects now. So in somewhat of a similar manner, if I am in a frame which is accelerated, so to be able to now look at other things, how they are with respect to me, I need to first make my own frame inertial. So to make that, I will have to now assume a negative acceleration on my frames, make it inertial first. And now
whatever adjustment I have made to my own frame, I will end up making to the frame that I'm observing, and that will sort of giving me a window into uh, what forces are acting or how much. Then the mathematics of that becomes easy for me. So can we think of pseudo forces like this?
We can think like that. It is just like similar of that what you have said, but it is not exactly work on when we discuss about basically some rotating frame of reference. Because in rotating frame of reference, what kind of pseudo force you know? In
Okay.
rotating frame, what kind of pseudo force you know?
So, sir,
Only
but thinking
centrifugal
aloud,
force,
Centrifugal
centrifugal,
force.
only centrifugal force or something else?
no, see, I think in this case, we should be, I don't know, I'm just thinking aloud. We should be thinking a pseudo torque and not a pseudo force, really. Because
Where?
so
Where?
if the frame itself is, so the torque which is making the thing accelerate, if we are in an accelerated, so are we talking about an accelerating frame, or are we talking about a
Accelerating frame, obviously, matlab non-inertial frame of reference we
सी
are talking about.
जस्ट बिकॉज अगर वो सिर्फ रिवॉल्व भी कर रहा है विद कांस्टेंट वेलोसिटी आल्सो, then in that event it is it is non inertial because acceleration है, because
Yes,
direction change तो फिर भी है. So
yes.
to make it inertial, whatever. Okay, so you're saying,
सर ऐसा आप डिफाइन मत करिए कि टू
हाँ ठीक है.
मेक इट inertial. It is no doubt indirectly what you want to say. I understood. You want to say if we want to apply Newton's second law, that's why we are doing some adjustment. Indirectly, you are saying if I say if I want to apply Newton's second law, where I'm applying Newton's second law in non-inertial frame. So definitely I have to do some adjustment.
Mhm.
If I am doing some adjustment, by doing that adjustment, inherently what you have communicated just now, that is fantastic. One of the outcome of this discussion is that I am inherently now assuming somehow non-inertial frame as inertial frame. Then only I can apply. And for that's why I am applying some pseudo force. FV is this is what you want to convey, I think, right?
Yeah, sir, the way you have put it, I think that also is making sense.
Ah,
Yeah.
because the this kind of description you have given, it will not work on the basically rotating frame. That's why I pause you on
Okay,
that note.
okay, okay. All right.
Okay, okay. So now in our cases, that alpha is equal to A. For all translating cases, alpha will A. For all other rotating things, I will explain you how alpha will change. Let's move to our next discussion, and it is very important because from where something special happened in the physics. Where alpha is, just wait, what is meaning of when I say alpha vector is equal to A vector, I am retaining the same meaning of A. A is the acceleration of S dash frame with respect to inertial frame. This is meaning of alpha. You always remember what is alpha. Alpha is basically A vector, and A vector is basically acceleration of S dash frame with respect to inertial frame. Then this FP will work. Let us move ahead. This is the question. Please take time of 1 minute and answer it. Some underlying assumption I want to convey here. This is basically an a stationary lab frame on the Earth where Einstein is doing some theoretical experiment, just assuming something. Suppose I have a ball, I am dropping the ball, then ball will drop. Again, he is thinking some theoretical way. Suppose everything, including my house, is inside spaceship, and spaceship itself moving with acceleration a is equal to 0 in the deep space where this spaceship is not interacting with any of the body of universe, means there is no other forces acting on this spaceship, then what will be the correct option? Very nice. Can we discuss? Still answer are coming. Okay, most of the participant had chosen option A along with other option. But Rahul Saini sir has chosen all the option. AP Sri Lata ma'am has also chosen all the option. Ma'am, can you please elaborate why you have chosen all the option?
Uh, Sir, what I felt was like if I take the first option, there is no difference between the motion of the ball in both the cases as observed by the man. So if I try to see that, what I understood was it's in the gravitational field, so it's going to come down with the acceleration g, and in the lab space there is no gravity, but the spaceship is accelerating upward, an acceleration g. So my first option seemed to be right for me. And the second option, they're saying there is no difference in the motion of the ball in both the cases. So what I thought was the man will see the ball coming towards the floor with an acceleration of 9.8 meter per second square. So, I mean, and in the Earth reference frame, the motion of the ball in both cases are different because outside the observer sees the ball is accelerating towards the ground. And in the case B, if I look at an outside observer, that is, if I look at from an inertial frame, he will see the ball is going to move up with a uniform velocity, a constant velocity. And maybe it doesn't sound well, but I thought the floor will accelerate up to meet it. I mean, I don't know if I'm right or not. And the case C is saying is once released, the ball is going to come with a uniform velocity in terms of the reference frame of the Earth. So there is no horizontal and vertical force acting in space. So it should continue move in a straight line, first law. And the last case, I thought it is coming down with an acceleration g from the um, man's reference frame. So it should be accelerating the man's frame. It should be accelerating with plus g. So there has to be a pseudo acceleration of minus g from his frame. If you look at it, that's what I thought. So I don't know, I'm right or not.
No, it is absolutely correct, obviously. Uh, do you considering pseudo force here in case of B?
In the case of B, if I say the option, the statement that was given was in the reference frame, motion of the ball in both the cases are different. So what I thought is an outside observer is an inertial frame. So he should see the ball coming down with a uniform velocity.
Ma'am, can you
That's what I
explain
thought.
option for option D once again? Why it is going down? G is
That ये
basically
मैंने
downward.
सोचा, I don't know how right I am. So
You are
what I
absolutely
thought
right.
was,
You are absolutely right. But I want to understand only why you have thought like that.
so जैसे कि in case B, once they're released, they're saying the ball is coming down with an acceleration g with respect to the man's frame of reference, right? So because the man's frame is accelerating upward with a plus g acceleration, so any object what do I say? It's not accelerating. Will appear to have a pseudo acceleration in the opposite direction as minus g from his perspective. That's
Hmm.
why I thought option D is right. I don't know.
Okay.
Maybe I'm wrong. You could give me better insight for this.
No. You are correct. Anybody has some other opinion? What ma'am said? Mamta ma'am, you have chosen only option B. Why?
Uh, B option appears actually in B option, earth frame, when in first case, when the man drops the ball, only gravity acts on it. And in another case, the gravity acts and upward force also acts and they cancel each other. So they are different. In the second case, net force is zero. And in first case, there is net force, that is gravity, due to gravity.
Okay.
And other options I couldn't understand. Sorry.
Okay. What about others?
So for the last one, we can also think of it like the man is already inside the space shuttle, which is accelerating with g. So his own acceleration will be, he will be oblivious of his own acceleration. So the only way he'll be able to explain the movement of the ball will be that there must be a downward force acting on the ball. That's why it hit the floor or it went towards the floor.
Downward force means it's pseudo force or something else.
See, in this case, because the moment his hand gets removed from the ball, now no force is acting on it. As long as the ball was in his hand, it was accelerating with the same acceleration.
Sir, when you are saying no force is acting, with respect to what you just asked yourself question, with respect to which frame no force is
His
acting?
own frame of reference.
No.
This minute.
One frame is what frame?
Sorry.
Just ask. One frame is what frame? Spaceship, space shuttle. Space shuttle is the frame where he is standing. If he assumed spaceship as his frame, obviously acceleration will we cannot attribute to acceleration now. It will be now stationary. Once it will be stationary, I said we have to apply pseudo force concept. Then force will appear.
Yeah, correct. So that's the pseudo force that he'll have to apply, no? To
Yes.
explain that. That's what I said. That to explain the movement of the ball, he'll have to apply a pseudo force.
Okay. Let us discuss. If anybody has some different opinion, then he can speak about this, and accordingly, if we will feel ki our options are not correct in A, B, C, D, then we will change accordingly also. Suppose. Yes, sir.
Hello.
Hello. Yes, ma'am.
I have actually selected only A, B, C, but now I feel that even D is correct in the sense as long as the ball is in his hand, it is stationary with respect to him. And when it is released, it is going down with respect to him with the gravitational acceleration G. It is only with respect to that man in that lift, I mean in the spaceship.
Let us start, ma'am, one by one. Here is the ground frame of reference. Forget about all the things here like lab frame, lab or something else. Just forget about this. System is now what? The eye of the bird is now ball. I have considered ground frame of reference, and from which I want to basically find out the motion of this ball. This is system. This is basically our frame of reference. Just consider what forces are acting on this basically ball. What forces are acting on this ball? Definitely mg.
MA and mg. MA in the
No.
upward direction and mg in the downward direction.
Ma'am, whenever you consider ma as a force, that means you are considering a pseudo force. Pseudo force will never appear in the inertial frame. Don't mix the concept. Don't mix the concept. Otherwise, everything will be wrong. Here we have to consider only mg. Gravitational force is acting. That's all. We will not consider any drag kind of force because we are assuming no drag force is acting on this ball. This is our assumption. This is the direction of acceleration. I cannot show this as m into a in this direction. You will get the answer, but it doesn't mean that you are doing proper justice with this ball with reference to ground floor. So this is basically acceleration, which is being generated by this force only. Now write the equation. mg is the force is equal to ma. Now a is equal to g. And we know very well, if the acceleration is constant, something happened special. We can predict, we can predict displacement s very easily with the help of these equations. Why I have chosen here negative sign? Because the direction of y I have chosen in the upward direction. That means if I take s is equal to minus h. Why I have taken minus h? Because the ball is coming down and the direction of y is positive in this direction, but ball is coming down. That's why I have chosen minus, and h is basically the height of the ball from the floor. And if I put this minus h here, I will get the answer how much time it will take to hit the floor. This is basically explanation given by the ground floor for case A. What about case B? Let us understand. Again, I consider a frame of reference, a ball, my system, assumption. What assumption we are considering here? No other gravitational force is acting on B, because our spaceship is in something deep space where no gravitational force exists. This kind of assumption we are doing. Even there is no drag force kind of thing, right? Under this assumption, what force are acting on this ball? Can anybody tell me what force are acting on this ball? सब चुप हो गए, प्लीज ऐसे चुप मत रहिए, बिकॉज लॉट्स ऑफ थिंग वी हैव टू डिस्कस और मुझे फटाफट लेना है.
Sir, MA downward.
What is that? MA, you want to consider MA as a force?
Yes, sir.
MA is the force. What do you mean by MA? MA is the pseudo force.
Yes, sir, pseudo force.
But I am taking here ground floor. It is an inertial frame. In inertial frame, there is no force.
Okay. So we are doing this from the ground of frame of reference, but we are taking case 2.
Yes, case 2. I want to analyze case 2 with ground floor itself. What force will act?
Then, sir, no force will be acting.
Yes, no force will be acting. No, since there is no gravitational force, space shuttle is not interacting with any of the body of universe. It is just moving with constant acceleration a is equal to 0. Right? What about the velocity? Whether velocity, as I have considered here, 0, or is there some velocity will be here?
So 0.
Okay. What about others?
Constant.
It moves with
Yes.
constant velocity.
Yes, there will be some constant acceleration. Not constant acceleration, sorry. There will be some inertial velocity. So initial velocity. There will be some initial velocity. Why initial velocity will be there? Because the space shuttle is moving with acceleration g. That means uh, the time I have chosen t is equal to 0. Definitely, ball, space shuttle, including that person inside the space shuttle, everybody has the same acceleration u. Same acceleration in same velocity u. Everybody will have the same velocity, and that will be the u. u. And after that, as there is no force acting on the ball, this u will remain constant throughout our observation. And the observation was up to only when the ball hitting the floor. Up to that time, the u will be constant because there is no force, no gravitational force. Force is not present. If force is not present, a is equal to 0. If I want to attribute like a, then acceleration will be 0. When acceleration is 0, means u will be constant. Whatever initial velocity, it will be throughout the motion. That's why here u is the constant in upward direction. And S1, after t time, the displacement of this ball will be upward, and that will be denoted by u into t. What about space shuttle? Just think about this. Space shuttle is moving with acceleration g. What is the velocity after t time? T is equal to 0. At t is equal to 0, ball, space shuttle have the same velocity, that is u. But after t time, it will become, for space shuttle, v is equal to u plus gt. Because space shuttle is accelerating, not ball. Once ball is left from the hand, ball is free. That is not part of the space shuttle. As long as ball is held by the person, it is one kind of, you can say, part of the space shuttle. It is moving with the same acceleration. But once it is released, no holding force is there, no gravitational force is there, then it will move according to the applied force, and applied force is 0. Once applied force is 0, then u will be the constant throughout the motion, and accordingly this S1 will be defined. But in the case of space shuttle, g is always present, including this person here. And the v is, after t time, the velocity of this space shuttle will be v is equal to u plus gt. And the the displacement will be given by ut plus half gt square. What about S2 minus H1? S2 minus S1 will be the H. You can see S2 minus S1 is basically half gt square equal to g. In the both cases, the time taken by the ball to hit the floor will be same. Either this case or this case will be same. That means if you think like that, the phenomena is doing the similar thing. Whether in case of A or in case of B, their physical significance is some kind of same reality, but their explanation will be different. I am just giving a hint on that. Let us analyze this case 1 and case 2 with reference to basically non-inertial frame. In non-inertial frame, with respect to man. With respect to man, in case 1, frame of reference is inertial because the whole this particular house built on the ground itself is stationary, we are assuming, or moving with constant velocity because we have attributed it is as like inertial frame. Then you can say the frame of reference of this person is also inertial frame for case A. And what force is acting on this? On this ball, mg is acting due to the force developed by the ground. But in case of B, the frame of reference of this inertial, man is basically non-inertial because this man is standing over the floor and the floor is accelerating with respect to ground. That means the frame of reference of this person is basically non-inertial. Once I understood my frame of reference is non-inertial and I want to analyze the motion of any particles, then I have to apply a pseudo force. The same concept we will apply here. I will apply a pseudo force, and that is equal to ma in opposite direction of the acceleration. and the acceleration of this frame of reference is basically is in this direction with respect to inertial frame. That's why I am applying pseudo force in this direction. Ma is equal to mg. Now tell me practically, in case 1, the force was gravitational force, the value was mg. In second case, the force is pseudo force, the value is mg. Can you differentiate? Can you differentiate both mg if you are doing some experiment? We cannot differentiate, because I really don't know. If I don't have any understanding that I am in a space shuttle, I am moving with constant acceleration. If I don't have this kind of understanding, this kind of knowledge, then I really don't know by doing this experiment whether this ball is attracting towards this floor by with the help of gravitational force or with the help of pseudo force. I really don't know. We cannot differentiate both the cases, case A and case B, with respect to man, because man has not understanding whether he is standing on the earth or he is standing on the uh, space shuttle. He will think only that yes, my ball is going down. That's all options I have shown was basically correct. And this is the basically concept which we call Einstein principle of equivalence. And from here, he started to think about whether the gravitational force is reality or something else. And he landed up to a special branch which we call general theory of relativity. From this thinking only he has started how the space and time correlate, and बहुत सारे mathematics करने के बाद he find out something else. This is beyond this course, even I don't know about that too much. So let us confine ourselves whether G or A with respect to this person. We really don't know whether force acting on this particular ball is gravitational force or it is due to the pseudo force. With respect to this man, we cannot differentiate. This is concept behind this particular example. Let us take another example, and this is very interesting and it will help you to understand about the rotating frame. Suppose
Sir,
I
one
have a
doubt.
disk. Yeah.
In case if the spaceship is accelerating upwards at an acceleration greater than g,
Yes.
in that case, how would we explain this? That inability to differentiate between mg and the fictitious force.
Ma'am, in that case, we will find some difference because now we have changed some reality. What we have changed? We have tweaked the question. We have taken A is greater than G, or we have taken A as less than G. Then the question is something different, because now the question is framed accordingly. We cannot say both two concepts are equivalent. It is not mean like that. He want to highlight, uh, as we are thinking G as a gravitational force or in terms of gravitational field, but he also want to highlight it may be it is not field, but it can be like pseudo force. He want to highlight like this thing. That was the only purpose. Are
Okay,
you
sir.
getting my point, ma'am?
Yes, sir. I understood.
The purpose was something else. He want to see differently. He want to
Hmm.
see gravitational force as pseudo force. That's why he denoted the acceleration of this spaceship as g.
Yeah.
He could have taken some other value also, but he cannot attribute like it is due to the pseudo force. He want to explain G may be something, some pseudo force kind of concept. He want to establish like this thing. That's why he explained this way.
Okay, sir. Okay, sir. Thank you.
This is basically a disk. Disk is rotating uniformly with constant angular velocity omega. A box is placed over the disk and which is also rotating with the same angular velocity omega. That means there is no relative motion between disk and the box. What a ground observer, suppose this person is a ground observer and he is observing this phenomena. How I will solve this problem? Anyone please?
For him, the box will appear to rotate with angular velocity omega as the disk is rotating.
Yes. That means what? For motion, for circular motion, what is responsible?
Centripetal force.
Centripetal force or centrifugal force?
Centripetal
Centripetal.
force.
Centripetal force.
In the
And
non-inertial frame, it would be centrifugal.
okay, okay, ma'am. Thank you. Then, what is here centripetal force basically from the ground for the ground observer? What is centripetal force here?
Friction.
Friction. Or m. Suppose the mass of this box is m, or m omega square r is centripetal force. Whether m omega square r is centrifugal force or friction is centrifugal force. This is my specific question.
Friction, sir.
Friction.
Centripetal will be friction.
Centripetal will be friction, right? That means to move any particle in circular path, we are well acquainted with the concept. A centripetal force is required. Centripetal force always act towards center, independent of the position in the circular path. Is it clear to everybody? Obviously, it will be clear. There is no such important concept behind this, but it will become an important concept. This omega square r is basically centripetal acceleration. Fr is basically centripetal force. Fr means friction force acting like towards center. And Fr is equal to m omega square r. I have written omega square r in bracket specifically to show it is a acceleration, radial acceleration, matlab acceleration towards center. That's why I have written here in the bracket, right? Now, m omega square is not centripetal force, rather its value is equal to centrifugal force. This is typographical error. So you just remember m omega square r is not centrifugal force, rather its value is equal to centrifugal force. We can say. What about when we see the same thing from the rotating frame as dash? How we will explain this? How the motion of this box we will explain. Basically, the box is not moving here with respect to disk, but rather it is stationary. How can we explain this?
So then centrifugal forces we say, which is pseudo force that is acting.
Yes, yes. In which direction centrifugal force will act?
So away from the center.
Away from the center. That means in this direction, right?
Yes.
And what will be the equation now? As we have applied the pseudo force, then remember the concept. What was the basic equation we have? F external plus F pseudo force is equal to M into A dash. A dash is equal to here 0. F is equal to basically Fr M omega square R.
Sir,
I think this will be the equation, right?
Yes, sir, yes.
Yes. Okay. Now tell me whether this tree will be rotate or not with respect to this frame of reference.
Yes.
So it will
I think
revolve.
others would interact also.
So it will revolve.
Yes, it will revolve. So what force is basically acting on this to revolve this particular tree? Vidya ma'am, I want you should reply on this.
Coriolis force.
Sorry.
This force.
Centripetal force.
But we are in the rotating disk of frame. Can we say centripetal force is acting on this tree? Are we
Fictitious
allowed to
force.
say?
No, sir.
Fictitious
Are we
force.
Coriolis force.
Coriolis force? Okay, we'll come to that. But first tell me whether are we allowed to say something about centripetal force in disk, frame of disk? Are we allowed to say this is the tree has centripetal force, centripetal acceleration or centripetal force?
No,
No.
sir.
No.
No.
Why no, ma'am?
It is now an inertial frame of reference.
Okay. Non-inertial frame of reference.
It is basically an inertial frame of reference, but when we are in the non-inertial frame of reference, and that is a point of view, then it itself is a inertial frame of reference. And fictitious force start acting on bodies which are not connected with it.
My ma'am, simple question is that are we allowed to say like this this tree is revolving around the center of this disk due to centripetal force? Are we
No,
allowed to say
no,
as per
no,
definition?
no.
Sailesh sir, what you say?
May I say something?
Yeah, ma'am. Sure.
What I feel is now the force which where the tree is outside the disk, the force acting on the tree is not along the radius vector. It will be tangential to the circular path that is shown here. So we feel it is going backward, but it is not. There is no force acting along the radius vector.
Okay. That means you are not attributing like that there is no centripetal force kind of thing.
Yes, I couldn't consider it a centripetal force.
Okay. Because it is non-inertial frame of reference, right?
Yes.
That's why you are not considering the centripetal force.
Yeah, right.
Yeah.
Sir, can we think of it like this that if I am on the disk, I will not feel as if the disk is rotating. I will see that trees are going around the disk in the
Hmm.
opposite direction. But now the
Hmm.
thing is that if they are going around, then they should be then centripetal force should have been acting on them
Yes.
because they are not physically being able to reach me. Therefore, to compensate for that, I will have to assume now an outward force acting, which is uh, preventing them from like moving towards the center.
Okay.
So
Okay.
where is this man? Is he at the center of the disk or where?
Ma'am, don't look about this man. It is just a symbolic form. You just think about our frame of reference S dash is fixed at the center of disk. It is just symbolic. Just omit this observer.
Okay, so
It
frame of
it always
reference is at on the axis, right?
yes.
Okay.
That's why I told in very first class, uh, don't see observer like a real human kind of thing. It is just a symbolic form of the frame of reference. That is what we take in physics. Actually, I have not much more time. I am just explaining this at the
At the
earliest.
center, sir, omega is equal to 0.
Omega is equal to 0 for which body?
Center, at the center of the circular path.
For which
It
body,
is
ma'am? Omega is equal to 0?
at the center of the disk?
Ma'am, we have, as we have assumed disk as a frame of reference, we have already considered disk is now stationary.
Omega
Disk is
equals
not
0
rotating.
for
I have
the
not
tree.
shown here any rotation kind of symbol. Now disk is stationary. Disk is
Okay.
completely stationary. That's why these trees are moving around the center of the disk.
Okay.
Is it okay, ma'am?
Yes.
But if there is rotational motion, you know very well with the help of rotational circular motion, if there is circular motion, there will be centripetal force, irrespective whether we are in inertial frame or whether we are in non-inertial frame. The concept is very simple. If there is circular motion, there is centripetal force. If this observer is observing tree is revolving around the center of disk, that means with respect to frame S dash, this tree will have a centripetal force. First, you by heart realize this. Without the centripetal force, circular motion cannot be possible. Only centripetal force will act. First, you realize it. Then we will find from where the centripetal force is coming on. That is altogether different thing. Now, as I told earlier, with respect to frame S dash, I have to apply pseudo force always. Likewise, I have applied here m omega square r. Suppose mass of this tree is capital M. I have to apply m omega square capital R, because capital R is the radial distance between tree from the center. But you can see here the force is outward. But as per our understanding, the centripetal force should have towards center, right? So where is the problem? What I am doing wrong? Can anybody tell me?
Sir, it should be towards the center.
It should be toward the center, because this is I told earlier, with respect to frame dash, everything is in reality, everything is happening in reality. He cannot say I am assuming this is moving, not like that. I am not assuming. With respect to frame as dash, whatever is going on, that is going on. That means I have to apply a centripetal force in this direction, but I am not able to figure out which force is acting in this direction, whether it is friction force or something. I don't know really. Anybody knows about this force? What force is acting in this direction?
Sir, capital M omega square R, should it not be centrifugal force?
Yes, this is centrifugal force.
Okay, yeah,
I am
fine.
saying this is centrifugal force.
Okay,
This is
okay.
not centripetal force, because this is pseudo force.
Right.
This is centrifugal force. This is centrifugal force. But my question is, a centripetal force must act in this direction. Then only this tree will revolve around the center. Otherwise, this tree will not revolve. So where is the catch? Where I am doing mistake? And suppose, so it's just revolving around this center of the disk. Then just define what will be the centripetal acceleration. Just define what will be the centripetal acceleration from the knowledge of circular motion.
V square by R.
V square by R, or in terms of omega, we can say
Omega
omega
square R.
square capital R, right?
Yeah.
But here, and in terms of force, it should have definite value m, capital M omega square R, right?
Yes.
But I am getting m omega square R in opposite direction. Suppose due to some reason, I am able to justify in this direction 2m omega square R is working, then my problem will be solved. I have to only justify 2m omega square R is working in the radial direction, right? Can I justify with the help of something? We can justify with the help of something that is very special name known as Coriolis force. Coriolis force is also a pseudo force. It acts only when the velocity of a particle appears with respect to frame S dash, nor inertial frame S dash. Rotating. It was rotating with respect to inertial frame, and with respect to non-inertial frame, if any particle has velocity, then this Coriolis force is defined like this. Historically, this Coriolis force was defined by the scientist like double of the centrifugal force, because 2 appears here.
The relative
Now the
velocity
thing,
between, sir, can I say something? The relative
yeah,
velocity between the disk and the ground.
not ground, tree.
Sorry,
I am a
I mean the tree.
tree,
Relative velocity of the tree with respect to the disk can be taken as 2 omega.
not 2 omega, ma'am, not 2 omega. This is a standard formula. This is a standard formula. Just understand what is written here. Minus significance for basically pseudo. 2,
Omega
2 is
minus
just an,
minus omega, sir. Omega
huh?
of the tree towards left or in the say clockwise direction, if it is taken positive, and omega of the disk in the opposite direction as minus omega, then the relative velocity will be omega of the tree minus omega of the disk. That will make it 2 omega, right, sir?
Omega square you want to say?
No, sir. I think what ma'am is trying to say, and sort of, I think, makes some sense. It's like the disk is going around the trees in one direction, but if the trees were also moving with omega, then we would have not seen the tree move at all. But we are seeing the trees move in the opposite direction with omega. So, sort of, the difference is actually 2 omega and not omega.
No, not like that. Not like that. It is just a mathematical quantity, and that can be easily derived. Don't think about that. Don't think that way. You have just a knowledge S dash is not moving, but any particle which is stationary with respect to inertial frame will move when we will consider S dash as an inertial frame. That's all. Don't think about much more from where this equation is coming from. This equation is definitely coming from the some mathematical uh, problem, or solving the things in the non-inertial frame. That way it came, but don't think the way you are thinking. We cannot justify directly on that way. Now the my submission was only that with respect to disk frame, this tree has a velocity v dash. You can see omega cross v dash. V dash is in this direction. Omega we are retaining the same direction which it was earlier, and that is in vertical direction. Now the cross product of the two, omega cross v dash. V dash is basically in tangential direction, and omega is in vertical direction. The cross product will be in this direction, but the negative sign will revert in this direction, and the value will be 2m omega square r, because v dash is itself omega r. We know if it is revolving with the angular velocity omega, then the v dash will be omega r. Accordingly, this force will be 2m omega square r, and this force is basically Coriolis force. Now we have two force. First force is m omega square r, and second force is 2m omega square r. Resultant force will be m omega square r, and that will basically create a centripetal force. So remember, with respect to non-inertial frame also, we may sometime define centripetal acceleration also, but cautiously use this term. For which body you want to use, you have to cautiously use this particular word. Don't use centripetal force for this, because we are explaining in something different way. It is not revolving around the disk, but here the tree is revolving around the disk. So till now I have explained you two particular pseudo force. One is centrifugal, another is Coriolis force. There are other things which actually I don't have much time. I'm just concluding. Suppose you have an inertial frame and another is S dash is, sorry, this is the typographical error. This is inertial frame and S dash is non-inertial frame. Then alpha is basically defined by A. This we have studied just earlier. And if something S is inertial frame and S dash is non-inertial frame, again here the typographical error, and this car is moving with respect to A and a disk is rotating here, and with respect to this S dash frame you want to analyze the motion, then there's something special pseudo force come out, uh, and that is denoted by this particular 4 quantity, that is Fv is equal to minus m alpha, and alpha is characteristic by all these terms, and all these terms have their own meaning. First one is known as translation pseudo force, second one is known as centrifugal force, third one is known as Coriolis force, and fourth one is known as basically uh, Euler force. Euler force come to role only when d omega by dt is not zero, means all non all that means whenever omega is not constant, then Euler force will come into the picture. Whenever your point of axle is translating with respect to inertial frame, this translation force will come into the picture. You can see here this axle is basically accelerating with a naught. That's why this force of translation, matlab pseudo force of the translation is coming out. That means in the disk in general, yeah, in any rotating frame in general, there is 4 component of the forces. This is very important question, but I am leaving to you for the assignment for this particular question. One thing I wanted to tell you only, कि pseudo force is a mathematical quantity in inertial frame. Its material origin cannot be defined, but in sometimes we feel the pseudo force in non-inertial frame of reference, and sometimes we do not feel. Why we do not feel? It is very interesting story. Someday we'll came across this. I am giving you like a assignment and leaving you to a curiosity where we can feel this pseudo force as a materialist, as real as materialistic force, and where we will not feel the pseudo force. It is just like a mathematical quantity. What is important factor which defines or which signifies pseudo force as a real force, feeling as a real force in Newtonian in non-inertial frame of reference? You have to find out. This is my assignment for you all. Thank you so much. That's all. This is all about. There is lots of things we have to explore together. Even whenever you think something, you just note down. Keep curious to learn about something. Then only you can understand the real concept behind the all simple things which you are coming across during your class lectures. Thank you so much.
Yes, thank you so much, Basu Sahu sir. So we really extend our heartfelt thanks to Mr. Basu Sahu for his insightful expert talk. The clarity of his explanations and the interactive nature of discussion kept everyone actually engaged throughout. We sincerely appreciate the time and the effort he has taken to share his knowledge and expertise with us. The session has undoubtedly added great value to this workshop and will leave a lasting impact on all of us. I hope each and every participant agree with this. Now, before we move towards a concluding session, let me take a chance to have a feedback session from our wonderful participants. So I would like to acknowledge the wonderful engagement of all participants. Your thoughtful questions, active participation in discussions, and eagerness to explore concepts beyond the classroom have truly enriched this workshop. Your involvement has been the real strength of the program. Now we will proceed to feedback session, an important segment of our workshop where we eagerly look forward to hearing your valuable reflections, experience, and takeaways. We truly believe that your insights not only help us improve but also inspire fellow participants. To begin with, I would like to invite one of our participants, Miss Sonia, Assistant Professor from Kanya Mahavidyalaya Jalandhar, Punjab, to kindly share her feedback. So, Miss Sonia, over to you.
Thank you, ma'am. Good evening, respected organizers, mentors, and my fellow participants. It is my privilege to express my heartfelt gratitude and feedback at this conclusion of this wonderful workshop. Over the past few days, this workshop has really lived up to its title, that is Mechanics Beyond the Formula. And this has been a truly enriching and well structured workshop that has successfully fulfilled its objective of moving us beyond the formula based learning. Each session has encouraged conceptual clarity, analytical thinking, and real life connections, which has made the learning experience really engaging. The expert sessions were highly impactful and thoughtfully delivered. The use of the relatable examples, demonstrations, and clear reasoning helped all of us strengthening our basic understanding and concepts in mechanics. And this all while creating a very interactive learning environment. And one of the most valuable aspect of this workshop was opportunity to interact with the different participants from all over the country. And as a feedback, I would love to see more of such workshops in the future and possibly with the extended hands-on problem-solving sessions. So thank you for giving us such a wonderful opportunity and valuable learning experience. Thank you, ma'am.
Thank you, Miss Sonia, for your thoughtful reflections. Now it's a time to invite our next participant, Mr. Shashank Verma from Sharma Physics Classes, Hyderabad, to share his feedback. So, Mr. Verma.
Thank you, ma'am. Hi everyone. Really enjoyed the whole week. I can't believe it finished already. It feels like we just started a few days ago. So every single day after the session finished, so my guru is Sharma sir. He was my physics teacher 10 years ago in college. I still, I'm in touch with him. I talk to him every day. So I should discuss with a lot of excitement the things I learned here. And he was also very happy, and that he should turn into a 1 hour call right after our sessions. So I just felt like a student again, as if I was in my 11th, 12th grade, reliving physics again. And one of the key things for me was, I think I strongly believe as a teacher also that mechanics is the key to understanding physics, because a lot of fundamentals are taught here. And I just felt like the way all of you discuss those boundary conditions, the things that are not often said out loud, but they are hidden within the definitions, whether that's system, inertial, non-inertial, by looking at real life examples. That just sat with me really well. So I'd like to really thank Pragya ma'am, Jeevan sir, and Sahu sir, especially for your amazing talks. There's a lot of reflection for me to do, just sitting with these problems, solving some more problems. I'm now very excited to go back to HC Verma, do it again, to really look at these things, situations again, to think through them. So I'm really excited. And also I loved, the use of interactive sessions. And I want to, like, often I teach one-on-one or, in online settings, but I really enjoyed how the online setting also is very interactive. And, whether that's through chat or whether that's through polls, live speaking, uh, I just loved it. Even if I cannot maybe do that throughout the session, maybe I can at least do that in the first 10 minutes to create that excitement for my students and then go into problem solving. Like, nice balance between those two. So I'm just being with a lot of ideas and excitement. Um, and also I think it's a critical time where we are right now, with AI and all the I see my students just using AI to look at a problem and solving it and thinking that solving the problem itself is physics. So they're not spending as much time thinking about these aspects. So I think if we can inculcate these sort of discussions and these sort of thinking, that is what will help them when they go to college and in the future, when they have to actually apply the physics in the real world. So thank you so much, everyone. Even the facilitators, Neetu ma'am, and Meenakshi ma'am, thank you so much. And yeah, thank you so much, everyone.
Thank you, Mr. Verma, for your valuable inputs. Thanks a lot. Now it's a turn to invite Dr. Neelam Upadhyay from MIT University, Maharashtra, to share her thoughts and experience. So, Dr. Neelam,
I
our
think
pleasure.
thank you so much for this wonderful workshop also. I have attended your previous workshop, which was on framing the questions as per Bloom's taxonomy. So I would say that this workshop was a real eye-opener when it comes to practical application of what was taught in the previous workshop. And here I would thank all the resource person because they offered a very insightful perspective on how to approach a problem by focusing on conceptual understanding. In fact, all the discussions that were taking place made me realize how I can frame my questions to to just make my students curious to ask exactly these questions. So all these discussions were highly motivating. They clarified the concepts much in a better way. And I really thought, if at all, I can just raise the curiosity in my class. I mean, I may not have enough time to do because I understand there is a time constraint, but off the class, a student can definitely come back and ask me same questions. So I would really love to take this discussion in my class, frame the questionnaire, so that these students can go through it within their time frame, whatever time they need, and come back with questions. Even if out of, say, I have a class of 25-30 students, and out of that, even one student comes back with the question to understand a concept in different light or with some different perspective, I think I would have achieved my target. So thank you, all the resource person, for this wonderful and insightful sessions. Thank you. Really, thank you.
Thank you, Dr. Upadhyay. Really, it was wonderful to listen to you. I really appreciate all your reflections. Thank you so much. Now it's a time to invite Miss Rani Vaid from Lotus Valley International School, Noida.
Yeah, thank you, Neetu ma'am. And I would like to say thanks to IPT team, Dr. Meenakshi. I was also part of last workshop, which was based on assessment. And I would like to share this again, that after that workshop, the way now I look at my question papers, and I have started framing my own case-based studies and how I'm connecting the Bloom's taxonomy with the question papers, that was automatically coming in my approach after that workshop. And today, after this workshop, I was really literally wondering that today is the last day of this workshop. Oh, I still want to know more and more. So that was the beauty of the workshop, which was conducted last time, and this, that we want, like, we don't get bored. We want more, and we still that the workshop still hooked us to know more and to study more, despite the fact that we are sitting for, I mean, from 5:30 to 7:30, and I really do not know where the time is flying. And in other kind of workshops, sometimes I feel, oh God, when will it get over? But in this workshop, I was thinking, oh, it should go on. And secondly, I was wondering, when I was in school today, I was discussing the questions which Basu sir was discussing last time, that third law of motion, strong and weak, and then action reaction forces. I was discussing with my students, and I felt a kind of empowerment in me, that this workshop has enabled me to refresh my knowledge, to get to know about many new concepts, which I will admit that I was not really aware of. And then many misconceptions were cleared. Regarding the resource person, I'm really like Pragya ma'am's way. I was really wondering that she took just one real life example and connected all the things, forces, energy, work, and everything in just one problem. Why I was not able to look at that mechanics problem the way ma'am has done this. So I was wondering in that way. Regarding Jeevan sir, the how the mechanics we got to know, and Basu sir explained about the frame of reference, many misconceptions got clear. So thank you so much, and we are really looking for more such kind of workshops, and relative velocity and other concepts also. We really want that. Thank you so much, ma'am.
Thank you, Rani Vaid ma'am, for your so true feedback, so valuable inputs. Really, it was a insightful feedback from your side. And on the behalf of the organizing team, really, I feel blessed to have such a intellectual participants among us. So now it is a time to present concluding remarks of 1 week national workshop by our esteemed Professor H.K. Sahajwani. So before that, it's my proud privilege to introduce Professor H.K. Sahajwani. So Professor Sahajwani, an eminent physicist and educationist, holds a PhD in physics and is currently serving as a president of IAPT RC01. With over 47 years of rich experience in teaching, academic leadership, and research, he has made remarkable contribution to physics education. 82 years young, dynamic personality, Professor Sahajwani has held several prestigious positions, including Dean Academics at IEC Group of Institution, Director of AP IIT ST India, and Principal ST College Panipat. He has also served as a head of physics department for many years, shaping generations of students. He is prolific author with widely appreciated books such as Basic Course in Physics, Objective Physics, and Conceptual Physics for IAS. His academic contributions include over 100 research papers published in reputed journals. Professor Sahajwani has been a pioneer in educational innovation, developing experimental modules in the areas like laser physics, semiconductors, and Arduino-based experiments, and establishing R&D centers to promote student-driven learning. His work also extends to emerging technologies like 3D printing and nanotechnology, along with the software development for physics simulations. We are indeed fortunate to have such a distinguished personality with us today. So, Sir Sahajwani sir, over to you for your concluding remarks.
Thank you, Neelamji, for such kind words. And first of all, before I say something, I would like to apologize first of all that I could not attend many sessions because of some important health issues. And I have just listened to the various feedbacks given by the various attendees, and I am happy that they have given wonderful this feedback for this particular event. So a formal start is the distinguished chief patron, Professor P.K. Aluwalia, President IAPT, our patron, Professor Rekha Ghorpade and Meenakshi Sayal, Vice President of the zonal convener, our registrar from the University of the Kashmir, Professor Nasir Iqbal, and our esteemed resource person, Mrs. Pragya Nopani, Shri Jeevan Kumar Pandey, and Shri Basu Sahu. I could not attend many of the sessions, but I only attended the session of Pragyaji, and I know her from the large. I think more than 10 years. Again, I have been in her contact. She has been a wonderful teacher, and she has been teaching so many things in a wonderful way. Say I am thankful to the fellow present this presidents of RC 002, 03, and 23 and 24, and most importantly, our 66 dedicated participants. See, it was a wonderful thing that 66 participants joined this particular course, and I'm so happy. And I would like that this type of the sessions or workshops should be held again and again and again for me to learn so many things. ठीक है ना से I have been watching the short say messages given on this uh, this what to say messages were given, and I have been reading those messages. But I apologize that I could not attend so many things. As a president of the RC01, it is heartening to see such a vibrant cross section of the schools, educator, school research scholars, and the college faculty members gathered here in the realm of the physics. There are no national boundaries. See, there were three say three participants from various other universities from various other countries, ठीक है ना? And it is a very good to see that. The central question posed by the workshops is haunting. Are we teaching mechanics or merely training the students to apply the formula? Wonderful question. And it should this type of the question should always be there in the minds of the others, minds of in fact everybody. Are we really teaching physics? The answer is in normal 99 percent of the cases that we are not. We are simply telling the students the formula and how to apply this formula. But over a particular question, how to approach the same conclusion by taking the new assumptions and various types of the assumptions, correct? But and that is what everyone, and I was seeing that so many students were asking so many questions. I'm calling them students, although they are teachers. I'm sorry, but for me they are students. In fact, I am also a student. Yeah, and the for too long we have allowed physics to be reduced to the collection of the equation, but mechanics is not the a set of the recipes. It is not a set of the recipes. It is coherent structure of the reasoning. As I have observed the proceedings of the last 5 days, I am convinced that we are moving towards what I call as a pedagogical discipline. We are not just solving the X. We are learning to identify systems with precision and recognize the limits of our assumptions. See, these assumptions are very important in reaching a particular conclusion. Yeah, we have to start reasoning and start assuming certain things. Any theory, we have to assume certain things. The assumptions may be wrong, assumption may be right. Nothing is wrong and nothing is right. Okay? But then simply I heard, I learned from Pragya ji that by having the different the assumptions, starting with the different assumptions, you are able to reach the same calculation. So, Mrs. Pragyanopani or our nation awardee took us back to the basics and profound depth. Her examples of the man painting on the door and the staircase were brilliant in distinguishing between the force-based and the energy-based reasoning. Sri Jeevan Kumar Pandeji brought a microscopic level thinking to the screen. His demonstration with the half-fitted jars on the inclined plane was a masterclass in center of the gravity and the stability, showing us that rotation dynamics is a physical reality and not just a line in the textbook. Yeah. His patience in addressing every query regarding the free body diagram and the normal reaction exemplified the sincerity of the teachers that IAP stands for. Before I say a few more things, I have a special announcement also, and that announcement is National Conference at MIT. Our national conference is being held at MIT. It is the 40th national conference, which is being held at the MIT. Where of course, I am also at Noida. So it is MIT University is at Noida, and I invite almost all the 66, and of course the organizers of this session to participate in that conference, and contribute to the research, contribute to the various with the various other objects. You know that the AI is there nowadays, and research is taking place not in months, not in days, but almost in hours. So some researches can be done, and but of course, large number of the executive councils from the various they say IAPT will be coming to this session, and therefore my humble and request is to all of you to please attend that. Yeah. So this event will be confluence of the bright-minded of the physics education and research. It is designed to further our mission of bridging the gap between the theoretical knowledge and the pedagogical excellence. As a president of the RC01, I extend a personal and warm invitation to all the 66 of you present. The workshop has laid the conceptual foundation. This workshop has laid the conceptual foundation. The national conference at MIT will provide the platform to expand these horizons ever. We look forward to seeing your active participation in this. You are now I'm talking to everyone else now. Okay? You are now the persons for your own students. Yeah, you have learned so many things. The students have learned so many things. They are the resource person of their research person of their students, and I think they will be able to infuse in among their students the habit of asking question, as the and coming this say making certain assumptions and coming to the same conclusion after showing that the various assumptions lead to the to the same conclusion, and in all the cases ask them the teacher should ask the students, ठीक है ना, go and what is the pulley, isn't it frictionless? Let them go to the school class, ask the students, what is the pulley, isn't it frictionless? When you see the students, when you ask the students, and you see the students eyes light up because they finally see the torque inside and just writing the symbols, writing the symbol tau for the torque is not a good thing. They are learning so many things from this type of the organization, and these teachers who have attended this program, I salute them, and I wish that they should continue to, and say inside continue to produce the interest among the students, and develop the what I should say is develop the habit of asking the questions. I must congratulate Dr. Neetu Verma ji and the entire organizing team for the seamless execution of this online mode, as we look forward to final session on the Newton's laws and frame and dependence. Let us remember that mechanics deserves clarity and our students deserve coherence. Thank you for your dedication to the physics. Thank you. Jai Hind.
Thank you, sir.
So, thank you, sir. We extend our sincere thanks to Sehjwani sir for his inspiring and thoughtful concluding remarks. His words beautifully summed up the key learnings of the session and provided meaningful direction for all the participants. Now it is a time to invite our very dear and esteemed Professor P.K. Alluwalia, President IAPT. It is really a great privilege and honor to have with us President IAPT Professor P.K. Alluwalia, a distinguished physicist with vast experience in both theoretical and applied physics. He has made the remarkable contribution to higher education through his dedicated teaching, mentorship, and curriculum development initiatives. He has played a key role in fostering scientific temperament and nurturing young minds across the nation. Professor Ahluwalia is highly regarded for his deep academic insight, visionary outlook, and significant contributions to the advancements of physics education in India. His guidance has continuously motivated educators and students to pursue excellence and innovation. He has also been a constant source of encouragement and inspiration for all young members of IAPT. His positive approach, approachable nature, and motivating words have always instilled confidence and enthusiasm among members, encouraging them to actively contribute and grow within the academic community. Under his dynamic leadership, the Indian Association of Physics Teachers has further strengthened its mission of promoting quality physics education at all levels. Sirs, we are truly honored by your presence today and always, and humbly request you to share your valuable thoughts and insights with us. Over to Ahluwalia sir.
Thank you, Dr. Neetu. I am grateful. You are always very, very kind to me. I don't know from where do you really dig out those adjectives which I don't deserve.
You deserve it. It's from the core of the heart.
Uh, and a very respected Professor Sehjwani, very dynamic President of Regional Council of Delhi and Haryana. I think it has been a pleasure to be working with him. I think they really his work actually speaks. In the last 4 years, we have had many opportunities to collaborate, and I think we always benefited in terms of the new things which he brought on the menu of the IEPT itself. And with his vast experience, and it's unbelievable that he's so senior, but he's an untiring person. I mean, I can tell you stories about him, the kind of stories which I am a personal, experienced person about his effort, his intensity to look into the things and so on. Maybe some other time I will spend half an hour on him only. I mean, that's what I would like to say. My zonal vice president of IEPT, Dr. Meenakshi Sayal, I think she has set a new bar for other zonal presidents. Ever since she has taken over as zonal president, I think she has done wonderful programs. The last program on designing question items was one such instance which you saw, her dedication and zeal. Another very important task which she is handling for IEPT is let us understand and solve it, the Facebook page called Lucy. And it has been running for more than 3 years. It has already completed 40 months. So 40 months means it has celebrated Ruby Jubilee months in the last 3.5 years. And it is always, pleasure when you find that there are people on whom you can depend, because IAPT is a kind of a forum which is run voluntarily by the people around in the community. So if you are able to, get good people, I think that's your good fortune, I would say. And then a very respected Ma'am Pragyanapani. She is a very distinguished physicist, a passionate teacher, communicator. You have already seen her. And one of the biggest qualities which a teacher should have is the patience. And you must have observed in the lectures which she delivered the way she very patiently poses things and lets you appreciate, gives you time to, pause, think about what is being talked about. I think this is a kind of skill which we should really carry in our classrooms. Thank you, Ma'am Pragya, for curating this program, designing its content, and coming out with wonderful 6 sessions. Your team has done a great job. I believe that these kinds of activities in IAPT provides us a forum for renewal. We are teachers, sometimes we get into the rut of our tasks. And then we forget that, we also have to refresh our fundamentals. We have to really think about the concepts which we just straight away put before the students, and we feel that, they have understood it. Whereas the thing is the otherwise. And I think having more than 60 participants in this workshop speaks the kind of confidence which IAPT has built up for these kinds of programs. And it was not just a national program, it was an international program, because participants from other countries also were present in this program. I was able to identify members in this, participants in this program, like Rani, I could see Neelam, I could see, and there were many other people who, Dr. Vinod Gupta ji is also here, a very passionate teacher.
Thank you.
You should really, once again, go to Lucy and see how it contributes there. Go to his YouTube channel, what he does there. And then he is retired, but doesn't mean that he feels that I am all know things. Okay, it's not like that. Ready to come and listen, participate, and not feeling afraid of that if I am wrong, maybe somebody will laugh at me because I'm a senior person. I mean, that is what should be the spirit which should be, celebrated among teachers. I think as teachers, we also know a very small fraction of the real knowledge which we need to really transfer to our students. But if we are able to do that, that is great. And we are very fortunate sometimes. I always say that to my very close friends, that teachers are very fortunate because they go to the same class again and again sometimes. Only two sets of people go, teachers or the students who have not qualified that class that year. So we are very fortunate, and I know that as a good teacher, you will realize every class is a new class for us. It brings new experiences for us. Sometimes it gives a kind of a shock when a student asks a question and we look around and we say, oh, sorry, I don't know what is the answer of your question. I think that is the benefit of being a teacher. And we keep on, honing our skills every day. This program really looked at some very fundamental things from physics. When I was hearing one of the participants sharing his reactions, I was fully agreeing with him when he was trying to convey that we have something which has been conveyed to us via this program so differently. It was not a routine kind of a program, it was a very different program. Thanks to the information technology, we can have quizzes in between, we can have responses in between, and you can even, create a class which can be an anonymous class, in the sense that when you were responding to questions, you are not knowing who is answering the questions, options A, B, or C, or D, etc. And right from the very beginning, people very strongly feel that if you do mechanics well, you really cross a big barrier of fear from physics itself. Otherwise, physics scares people away. And that should not happen actually in the classroom. And the role of these programs is this only. And it also opens up a kind of a networking for us, where maybe tomorrow if you have some question, you can pose that question to Ma'am Pragya through email or through WhatsApp, and she will be very happy to respond to that. And that, oh, I am finding my participants who were there in that program are still interested in learning more from me. I think that's the biggest plus which you can really take away from here, that you have come across mentors who did certain things with you. They explained certain things. They motivated you to go once again, revisit the things, and try to learn things once again. And I can see that in all the lectures, there was no question of derivations. Most of the times, what we do in physics classroom is we will come and tell students, let us derive. And sometimes, even in the labs, we say, let us verify. We just don't tell them what is the conceptual foundation, how we are actually trying to create models around us. Our models are, which are discussed in the classroom, very far from reality. But then how to bring that reality into the picture? Professor Sajwani was talking about pulley, for example. Is there a friction or not? This is a very simple question which we need to really ask. And I think we need to convert our classrooms and labs into places for discovering things for ourselves. If we can do that, I think the quality of physics education will definitely rise. Ma'am Pragya is very much an expert in what we have been looking at, what we call about national education policy. Competency building. I think that was the main underlining element of this particular workshop itself. So when we are talking of competence building, we are not at all worried about what is going to be the answer. We are worried about whether we are passing through that process of thinking to arrive at some result through a systematic approach or not. I think you have revealed that kind of an approach in this particular workshop. And we hope to bring in future more such competency building workshops on various topics, both at school level, at undergraduate level, at PG level. And look at this concept of fictitious forces itself. This is not an ordinary concept, very difficult to appreciate and understand. And you will always find people will do derivations, where they will bring out the coordinate systems to explain the things. They will make a transition from Cartesian coordinates to some kind of coordinates which students hear for the first time. Then they realize that if we are working in, say, spherical polar coordinates, then our unit vectors are also not behaving in the same way as the unit vectors behave in Cartesian coordinates. And then we start discovering mathematically certain terms which we need to really understand by connecting them with reality. You must have seen in this session itself, Dr. Basu gave us a final formula where he had written cross products and all those things, which are again very scary. Whenever I have been, discussing things with my own students, I have always been emphasizing on one fact, and that is that when we switch over to algebra from arithmetic, we make a transition to abstract thinking. Second step comes when we find that algebra is not enough, we should bring in new elements into it. We bring in vectors to make our life simple and not tough. We should also really tell our students. And then the ultimate thing which happens in mechanics is exposure to calculus. And fortunately or unfortunately, when we are teaching physics in physics classrooms, at class 11 and 12, students are not exposed to calculus at all. And it is the duty of the teacher teaching in class 11 to tell them the nuances of calculus itself. I mean, this is a very, very challenging task. It's not an easy task. And if you are able to do that task and tell them delta t approaching zero means delta t is not equal to zero, but as close to it as possibly you can imagine, it's a big, big, revelation for them. So I believe that this workshop has fulfilled its aim and agenda and has brought more teachers in the ambit of Indian Association of Physics Teachers, and their support is needed. You should not just come here and tell us that, oh, it was very good. We are very much open to the kind of criticism which will make these kinds of workshops more, exclusively competent for us. That is very much important. I think we are fortunate that you can revisit these lectures which have been recorded, go again and again. एक ही तरीका है, अगर आपको कोई चीज याद करनी है ना, आपने देखा होगा गाने में भी ऐसा होता है, मुखड़ा हम बार बार रिपीट करते हैं। मुखड़ा आता रहता है गाने में, वो हम रिपीट करते रहते हैं, और वो रिपीटिशन जो है दैट फिक्सेस आइडियाज इन आवर माइंड. That is very, very important. So please don't hesitate in revisiting these lectures, because I know whenever we go for a lecture in an hour or 1.5 hours, we carry, say, 10% of that lecture with us. But by revisiting it, we can make it 20%, 30%, 40%, and appreciate sometimes in the first go, which we do not appreciate. This is also very, very important. And I am sure that this team of this program of resource persons will come out with some more such initiatives. You are always welcome to come forward and interact with the members of IAPT. And I would say congratulations to the participants that they had the patience to stick here for 6 days. Physics is not, Sugam Sangeet, it's a classical Sangeet. And sometimes when the classical song is switched on, we immediately rush to the radio and switch it off. Because we say, oh, no, I don't want to listen to it. Sugam Sangeet is very good, but appreciation for classical Sangeet makes Sugam Sangeet so pleasurable. We should not really forget that. Professor Sajwani also has given us a wonderful information. This year, we are going to have in the capital city of our country a IAPT convention, and it is the 40th convention of the IAPT. And it is again a Ruby Jubilee convention actually. So we are going to celebrate in a big way. Already the dates have been announced. From 4th of October to 6th October, this convention will be there. But let me also tell you, there is a very special feature of our convention, which happens a day before the convention. We call it pre-conference workshops, where in small groups, we actually bring together people, and there are experts who talk about different dimensions which are happening in physics at different levels. I think we need to really be there in Noida at MIT University. I am told that that is going to be a wonderful place for each one of us to visit. Noida has now a beautiful new, you call airport also, international airport. Maybe this time when we will come, hopefully we will land there and participate in that convention. Sajwani sir lives in Noida, so you can hope for having a good party there. So
Sure, sir.
also one of the positive things. Our convention has given a broad theme. First call is going to be printed in this April month's bulletin. Already we have put that on our website. I will request honorable members, honorable participants here, honorable resource persons, please do visit our websites off and on, because there you will see what is happening in IAPT itself. There are a number of very interesting pages there. One page which I always try to recommend is called Useful Web Links. Please visit that page and see that what are the resources which have been curated by IAPT on that particular page. Then there is a page which is dedicated to the bulletin itself. We have a repository of bulletins from 1984 till date, and that is full of nuggets, knowledge nuggets, I would call it. Our past presidents, our past members have contributed immensely in the growth of that bulletin. And I'm very proud to say that not even once we have missed printing of the bulletin, either on e-format or on the printed format. Then there is third page which we have created, which you should visit, for IAPT books. You will find that there are very interesting books which we have started bringing together, and we have started posting those books there. Professor Babulal Saraf's celebrated books on experiments in physics are already available there. Professor D.P. Khandelwalji's biography is also present there, and you must read it. That what was the spirit that IAPT was started and where has it reached because of that effort. When there used to be no computers, nothing, he would write down with his long hand, cut stencils, get the printouts, then write addresses and send those to the members. Single one-man army used to work at that point. Yes. Those are our inspiration to work. And I'm sure that if I now look at what has happened in this workshop, I wish Professor Khandelwal must be seeing what is happening in IAPT. He must have been celebrating this kind of work which is happening in IAPT itself. So, dear participants, once again, I thank you also for being part of this program. My heartfelt gratitude to the resource persons team who came, spared their valuable time. And I don't have any words to say what women in physics are doing in IAPT. You can see Neetu Verma ji, Meenakshi ma'am, Pragya ma'am, they are the woman face of IAPT. And whenever they are given any task, I was, in Jalandhar lately when a regional convention was held in Punjab. I cannot forget that convention, let me tell you. Such a wonderful convention with such good resource person. It was not for one day. It was for 2 days. And again, it happened in a women college. And there were so many, participants who very enthusiastically came to see that what IAPT does. And one very important memory which I carried from there was, there was a small, ramp show there on which Indian women scientists and physicists walked on the stage to tell that what they have done. So IAPT not only just thinks in terms of कि हमको बड़े serious जैसे कुछ topics पे बातचीत करनी है. We have to talk about those things also where we should feel that we celebrate what we call inclusivity on our platform of IAPT itself. I think I have carried my agenda of talking to you very far, but I don't want to miss these kinds of opportunities to talk to you. Once again, thank you very much. And my sincere gratitude to each one of you for coming and participating in us. And when you pay registration fee, you help us take these programs further. Our model is to reach the unreached. So this small contribution of yours goes a long way in carrying forward the vision and mission of IAPT itself. Thank you once again. Jai Hind.
Thank you, Professor Ahluwalia, for this very much enlightening talk. Now it's the time to call Dr. Neetu Verma, coordinator of the workshop, for formal vote of thanks. Dr. Neetu Verma, Dean Sciences and Head PG Department of Physics at Kanya Mahavidyalaya Jalandhar, serves as Innovation Ambassador and Vice President of Institution's Innovation Council. She has established Punjab's Anveshika Center under the Nani Initiative. Dr. Verma has received numerous awards, including Dina Bandhu Sahu Memorial Award for Innovative Teaching in Physics and Young Investigator Award. She holds 4 granted and 2 published patents and is the brand ambassador of IUPT. Dr. Verma actively promotes experimental learning through workshops and innovative quiz programs, enhancing students' engagement and strengthening the quality of physics education. Over to you, Dr. Neetu Verma.
Thank you, Madam Meenakshi Syalji. Thanks a lot for your kind words. Formally, a very good evening once again to Professor Ahluwalia ji, President IAPT, Professor Rekha Gorpade, Secretary IAPT, Professor H.K. Sahajwani, President RC01, Professor Jaswinder Singh, President RC02, Professor S.K. Tripathi, President RC03, Dr. Professor Kuldeep Kumar Sharma, President RC23, and Professor Nasir Iqbal, President RC24, resource persons of the workshop, Professor Pragya Nopani, Mr. Jeevan Pandeji, Mr. Basu Sahuji, and all respected dignitaries, esteemed guests, and their participants. As we come to the end of this enriching workshop, it is my proud privilege to propose a vote of thanks. I express my heartfelt gratitude to our esteemed President, Professor P.K. Ahluwalia ji, for his inspiring presence, visionary guidance, and constant encouragement that continues to motivate the entire IAPT fraternity. I sincerely thank Professor Rekha Gorpade ji in her absentia, Secretary IAPT, for her continuous support and commitment towards promoting quality physics education. I extend my deep appreciation to Professor H.K. Sahajwani, President RC01, for his valuable concluding remarks and for sharing his vast experience and insights with us. My sincere thanks to all respected regional council presidents, Professor Jaswinder Singh from RC02, Professor S.K. Tripathi from RC03, Professor Kuldeep Kumar Sharma, RC23, and Professor Nasir Iqbalji from RC24 for their gracious presence and encouragement. I would like to place on record a special thanks to Professor Meenakshi Syal, the convener of this workshop, whose dedicated efforts, meticulous planning, and constant support made this event a grand success. I extend my sincere gratitude to our wonderful resource persons, Madam Pragya Nopani ji, Mr. Jeevan Pandey, and Mr. Basu Sahu for their insightful, engaging, and thought-provoking sessions. Their expertise and passion truly enriched our learning experience. I also thank all the participants for their enthusiastic involvement, active participation, and meaningful interactions, which brought life to this workshop. Last but not the least, I extend my heartfelt thanks to all those who directly or indirectly contributed to the successful organization of this program. With this, we conclude the workshop with a sense of accomplishment and inspiration. Once again, thanks to all and Jai Hind.
Thank you, Neetu Verma ji. Thanks a lot. So participants के लिए जिन्होंने इतनी शिद्दत के साथ पार्टिसिपेट किया है, कौन कहता है कामयाबी किस्मत तय करती है, इरादों में दम हो तो मंजिलें भी झुका करती हैं. So now my request to all the members in this U meeting to switch on the cameras for group photograph. So please switch on your camera so that we can have the group photograph.
I want to add that somebody asked what is the official website of IAPT. I have posted that in the comments. Please have a look at that. It is www.indapt.org.in.
Thank you, sir.
Thank
Thank
you,
you.
sir. Thank you.
Thank you, sir.
Thank you so much, sir. Thank you so much, ma'am.
Okay. Thanks a lot to all the participants, resource persons, our president P.K. Ahluwalia ji, H.K. Sajwani sir. Thanks a lot. So now we will meet in another workshop. Till date, we will now do, still the work is there in this workshop. So please, all the participants are requested to submit the assignments in time so that we can send e-certificates to you all. Thank you very much. Thanks a lot.
Thank you, madam.
Thank you, everyone.
Thank you.